to the home of mathematics. In this video series, we will show you the milestones in the journey of human mathematical discoveries.
David Hilbert, 1862 to 1943.
David Hilbert was born in Königsberg, Prussia on the 23rd of January 1862.
Hilbert was a German mathematician and one of the most influential mathematicians of the 19th and early 20th centuries. He discovered and developed a broad range of fundamental ideas in many areas, including invariant theory, calculus of variation, commutative algebra, algebraic number theory, foundation of geometry, spectral theory of operators in Hilbert space, and its application to integral equations, mathematical physics, and the foundation of mathematics. Hilbert adopted and defended Cantor's set theory in transfinite numbers. In 1900, he presented a collection of problems that set the course for much of the mathematical research of the 20th century. He and his students contributed significantly to establishing rigor and developed tools in modern mathematical physics and general relativity. Hilbert is known as one of the founders of proof theory and mathematical logic. In 1920, Hilbert proposed the Hilbert's program, that mathematics ought to be formulated on a solid logical foundation. He believed that in principle this could be done to ensure, 1. All mathematics are derived from a finite system of axioms and manipulated according to well-defined rules. 2. Completeness. All mathematical statements can be proved in the formalism. 3. Consistency. There is no contradiction in the formalism of mathematics. Kurt, I would like to lay a solid foundation to mathematics to ensure mathematical statements and results could all be proved formally from a set of consistent axioms.
Well, David, that is not possible. By simple counting, I found that any consistent system with a computable set of axioms which is capable of expressing arithmetic can never be complete. It is possible to construct a statement that can be shown to be true, but that cannot be derived from the formal rules of the system.
That means we may not be able to prove Goldbach conjecture?
Yes or no, we're just not sure whether Goldbach conjecture is provable.
Dehn, given two polyhedra of equal volume, is it always possible to convert one into another by cutting it into smaller pieces?
No, sir. As the sums of length, times, dihedral angles of the two polyhedra may not be equal, they cannot be converted to one another by simple cutting into smaller pieces, as this quantity is an invariant in the cutting process.
Professor, among the 23 problems, which one you would like to be solved the most?
Well, the Riemann hypothesis on the zeros of the Riemann zeta function.
Ah. You also want to win the prize money of $1 million.
Thank you for watching. Talent is important, but how one develops and nurtures it is even more so. See you at the home of mathematics.